Hello friends, today we are going to discuss the economic order quantity model and we will try to see and understand this model with the help of some example. Before we start, let me introduce myself. I am N.G.Shekapure, Assistant Professor in Production Engineering Department at AISSMS COE, Pune. Coming back to today's topic, EOQ. When we talk about inventory, we need to answer some questions like what to order, when to order, how much to order. Because inventory management is nothing but, or inventory control is nothing but a part of material management. When material management comes in our mind, we need to understand what are the costs associated with the material management. If you look broadly, we come to know that cost of material, which is the major cost. After that, ordering cost and the carrying cost. Now these three costs is going to play very important role in any material management and is the big challenge to minimize all these costs. Up to when we look at the cost of material, sometimes it is very difficult to minimize the cost, but for ordering cost and carrying cost, we have something to do and we are going to focus on ordering cost and carrying cost. These two costs are basically associated with the inventory cost. And when we look at this ordering cost and carrying cost, how they react and how they associated with each other, that we will try to understand. When we talk about the ordering cost, it depends on number of orders. So how many number of orders you are placing annually, which is going to decide the ordering cost. If you are putting less number of orders, the cost of ordering is going to be less. But if number of orders are more, then cost of ordering is going to increase. You can take a very simple example that annual demand of a particular item is suppose 10,000 rupees. And if you are ordering 1000 items per order, so we need to order almost 10 times to get those 10,000 items. And if we associated cost with that, suppose 50 rupees cost per order, so we are going to order 10 times. So what we can say that 10 into 50 is nothing but 500 rupees is going to be an annual ordering cost for those items. When we talk about carrying cost, most of the time the carrying cost depends on how much quantity you are holding in your hand at your warehouse or carrying cost. If you are carrying less inventory, it is but obvious that the carrying cost is going to be less. But if you are carrying more inventory, then the carrying cost is going to be more, or holding cost is going to be more. That we will try to understand with the help of graph. Now if you look at this graph, on the x-axis the quantity is given and on y-axis the cost is given. Now this blue line is associated with ordering cost. If the ordering cost or ordering quantity is very less, so it is but obvious that we need to order more, we need to place more orders. So the cost of ordering is going to increase. If we increase the quantity per order, so the number of order will be less, so the ordering cost will decrease. But vice versa, if you look at the holding cost, initially if you have less number of quantity, then what we can say that the holding cost or carrying cost will be less. But as soon as the quantity increases, the holding cost is also increases. So this is the graphical representation of ordering cost and holding cost. With respect to that, the total cost is going to behave and it will give a one certain point. That point is nothing but EOQ. So this is nothing but the graphical representation by which we can understand how much should be a economic order quantity. But before we talk about EOQ, first of all, we will try to understand the definition and assumptions of EOQ and how we use this EOQ in a mathematical model. EOQ is the optimum size of an order to replenishment of inventory is called economic order quantity. It is also called as a optimum order quantity. It is the size of order where total inventory cost, which is nothing but ordering cost and the carrying cost. We need to minimize this both the cost with the help of EOQ. But before we solve EOQ, there are some assumptions we need to take into consideration. So what are those assumptions? The first demand is known with certainty and it is going to be a constant over the period of time. But in actual scenario, this never happened. Demand is always fluctuating. It is depend on the market. But what we are considering over here, that the continuous process is going on and demand is known and it is going to remain constant. The second assumption says that no shortage is allowed. So there is no shortage of material from the vendor side also. That we need to take into consideration. The lead time for the receipt of order is constant. Now when we are talking about lead time is nothing but the point at which we place the order and another point at that point we receive the order. So whatever the difference or the time difference between the placing the order and the receiving the order, that time is nothing but your lead time. And every time in EOQ model we need to consider this time as a constant. Then order quantity is received all at once. Suppose your order size is 1000 rupees, we are 1000 quantities. So what we can say that the 1000 quantity will received at once. It should not happen that you will get 800 quantity and after some lead time you will get another 200 quantity. So this type of assumptions we need to consider under EOQ model. We will try to elaborate this EOQ model with one more graph in which what we are taking into consideration on the x-axis is time and on y-axis quantity. Now here we can say that at this particular point this is the demand of a company. Now in a continuous production the consumption of that material is going on, but at certain level we need to take decision that we need to order so it will reaches to us, so it will not interrupt the production. So that particular point is called as a reorder point. So we are going to reorder point, and this reorder point is most of the time depend on the lead time. As we have discussed, lead time is nothing but the difference between the order placed and the order received. That buffer should be there. So what we are considering that this lead time is going to be constant, and as soon as you reaches to your inventory 0, again it gets top up to your demand, which is the maximum one. So like this curve is going to be a continuous. So this curve is under assumptions of EOQ. Now what we'll do, we will try to understand how to solve a problem of EOQ with the help of formulae. So formula method, it is also called as a square root formula or Wilson formula. Okay, the notations are given. Q is nothing but a order quantity. So how much we order each time. D, demand. So how much demand per year. Then V is the value per atom or purchase cost or a production cost. O is order cost, placing and receiving that order. And C is the inventory carrying cost. And EOQ formula says that under root of 2OD by CV. So we will try to understand it with the help of example. If you look at this example, what they are asking simply to calculate the economic order quantity from the following particulars. Annual demand is given. So annual requirement is nothing but 2000 units. Then cost of material per unit is 20 rupees. Cost of placing and receiving one order, means it's the per order, is 40 rupees. Annual carrying cost of inventory, they are given it in percentage. So 20% of inventory value. So if you put it in the data, what we come to know that they have given annual requirement, product demand, D is 2000 unit. The cost of material per unit is the product value is 20 rupees and order cost is 40 rupees O, and the annual carrying cost of inventory, which is nothing but the inventory carrying cost, C is 20%. Okay, in some of the cases they directly give you the annual carrying cost per unit. So when they give annual carrying cost per unit, so that is nothing but the CV. Here what we are doing, when it is given in percentage, we need to multiply it with the product value, which is nothing but a CV. That we are going to see in the next problem. Now, as far as this problem concerned, if you try to solve it, it is very simple. We know that the ordering cost is 40 rupees multiplied by 40 into demand is 2000 rupees divided by 20% means 0.2 into 20 is the value per unit or the cost of material per unit. So EOQ comes out to be 200 units. A very simple example to solve. We will try to solve another problem in which the given data might be different. Now here what they are saying, calculate the economic order quantity, total cost and order cycle time from the following particulars. What they have given, annual requirement is 10,000 unit. This is our D. Ordering cost is 150 unit, is nothing but our O. Inventory carrying cost is 0.75 per unit. Now this is nothing but your CV, because now they have not given inventory carrying cost in percentage, so that's why they have not mentioned the value per atom, because value per atom is most of the time associated with the percentage of inventory carrying cost. So rather than that giving percentage and V, value of V, so what they are given, they have given inventory carrying cost, which is nothing but directly CV. If we put it in a data, what we will come to know that D is nothing but 10,000 unit, O is 150 per order cost, and carrying cost in inventory is nothing but CV, 0.75 per unit. So EOQ is equal to directly 2VD divided by CV. 2 into ordering cost is 150. The demand per year or annual demand is 10,000 rupees and CV is 0.75. So EOQ comes out to be 2000 unit. But they also ask us what is the total cost. So if you want to find out the total cost of inventory, we already seen that total cost or minimum total cost of inventory is nothing but ordering cost plus carrying cost. Ordering cost O by D means ordering cost into demand, annual demand divided by EOQ or quantity we are going to order. Okay, just we got that it is 2000 rupees, and plus CV is nothing but the inventory cost. The quantity is 2000 rupees and divided by 2. When we put all the values, O is 150 rupees, ordering cost 10,000 is again demand, and Q is 2000. EOQ is our 2000 plus 0.75 we multiplied by 2000 divided by 2. So the minimum total cost come out to be 1500. They have asked one more thing is nothing but order cycle time. Order cycle time means that how much order we need to place in a year. So it is very simple to find out. We know that order per year is nothing but the total demand and EOQ. So the total demand is 10,000 rupees and ordering quantity is going to be 2,000 rupees. If we multiply 10,000 by 2,000, what we will get? We will get 5 orders per year. So we need to place 5 orders per year, and order cycle time is nothing but how much will be the time required for or the gap between two orders. So the 1 year, it's an annual consumption rate, so 365 days plus order per year. So we are going to place 5 orders. There are 365 days. 365 days divided by 5 equals to 73 days. So we can get order cycle time over here. So with these two examples, I do believe that the concept of EOQ is almost clear. In the next lecture, we will try to solve some other problems related to EOQ. Now, as far as the production engineering department concerned, it's a very special branch which is nothing but a sandwich pattern. Sandwich pattern is something which allows you to go for full 1 year industrial training during your engineering or during your graduation. When you pass out, you already have an experience of 1 year from a good company. So it is help you to get place, which is nothing but the demand of today's era. So with that, we have particular vision and mission. I will go through the vision: to produce responsible technocrats with industry participation, because industry is the integral part of a sandwich pattern. Our mission is to impart state-of-art technical education to groom students for today's dynamic environment, to enhance overall growth of students through industry institute interaction. For that, we have almost more than tie-up with 200 industry, because our students go to the industry for almost 1 year training program to make students learn to think analyze, express and create with technology, to equip students with attributes for entrepreneurship, employability and pursuing higher study. So with this, I like to say goodbye and thank you to all the students.